Hi everyone, myself Archana and my co-author Abhishek would present a quick demo on our technology showcase proposal titled Securing API Authentication on OpenStack Cloud. This intends to discuss the most secure way of authenticating REST API calls on the very popular open source platform OpenStack, which is the most widely used technology for building cloud environments. Let's get started. Keystone is an OpenStack identity service responsible for authentication and authorization. It validates the user's credentials at the time of login. Upon successful validation of the credentials, it issues a token that the user can use to make REST API calls. There are multiple token formats that Keystone supports. Let's understand them in detail. Universally Unique Identifier, known as UUID token format, is the most simplest and lightweight format suitable for simple OpenStack deployments. Keystone can be configured to use this format of token provider by updating the token section in the Keystone config file as shown. The UUID token format is not so popular since they are stored in the database that leads to an additional overhead during token validation. These tokens are also considered to be less secure since they are randomly generated 32-byte numbers in plain text format. Public key infrastructure token format is more secure when compared to the UUID token format since they are cryptographically signed tokens. They are built on the model of public and private key concept. The token validation is not centralized. The disadvantage of PKI tokens is that they are very huge in length. They are larger than the standard HTTP header size, hence not suitable to be specified in the XAuth token header section while making the REST API calls. PKI-Z is the compressed version of the PKI tokens, but they are not recommended. Fernet token format uses the same key for encryption and decryption. They are considered to be the most secure format of tokens. The key repository parameter in Fernet token section in the config file specifies the path where the encryption keys will be saved. Max active key parameter defines the number of keys that can reside in the key repository. Let's understand the various types of keys residing in the Fernet key repository. The key files will have file names as 0, 1, 2, 3, and so on. The primary key will be used to encrypt and decrypt the tokens. The key file with the highest index will always be the primary key. Secondary key will be used to only decrypt the tokens. The key file with name lower than the highest index will always be the secondary key. We can have multiple secondary keys in the repository. Staged key will be the next key file in line to be the primary key. The key file with index 0 is always the staging key. Now that we understood the various key files that reside in the key repository, let's look at the key rotation concept. Initially, there are only two keys, that is, the primary key file 1 and the next staging key file 0. After the first round of key rotation happens, the current primary key file 1 will become the new secondary key file 1 and the current staging key file 0 will be the new primary key with file name 2. Another new staging key with file name 0 will be generated. The key rotation concept ensures that the encryption key keeps changing constantly, thus ensuring a highly stable and secure cloud. Some of the benefits of the Fernet token format are that they are non-persistent. Fernet tokens are lightweight when compared to the other tokens. The Fernet tokens are secure since they are encrypted. The encryption key keeps changing constantly after every rotation happens. Zero replication lag for token validation. Performance is always optimal since the tokens are not stored in the database. Thank you. We hope you liked the video.